Okay, this is how to create ionic and covalent compounds tutorial by me. Okay, so ionic bonds is a bond that forms when atoms are held together by attraction between opposite charges. They have high melting and boiling points, conduct electricity in water, are hard and brittle, and exist as networks called lattices. So basically what they kind of do, I'll get a little more into it later. But basically they have all these electrons that I have represented with these collectible things. I don't know. Yeah, they're trying to satisfy the octet rule, and this one has 7. This one has 7, and the other one just has 1. And they're like, you know what? I don't want this. Have it. And then covalent bonds is a bond that forms when atoms share electrons in order to both get 8 electrons in their outer shell. They have low melting and boiling points, cannot conduct electricity. Compounds can contain single, double, or triple bonds, and they can be solids, liquids, or gases. And so I gave up on the metaphor on this one because I like the metaphor only makes sense for one thing. So yeah, that they just they have the electrons and they're gonna bond them, I guess. They're bonding. How to determine if a bond will be ionic or covalent. Ionic bonds transfer electrons, covalent bonds share electrons. The electronegativities of atoms in ionic bonds are very different, while the electronegativities of atoms in covalent bonds are a lot more similar. Ionic bonds happen between a metal and a nonmetal, and then covalent bonds happen between two nonmetals. So I kind of represented that with these two different groups. I don't know why these other two are so boring. They can be similar without being boring, but yeah, pretty much these first two on the left, they're an ionic bond, and so they're very different, and it's a metal and a non-metal. And then the covalent bonds, it's two non-metals, and they're a lot more similar. So my ionic compound was bleach, also NaClO. And so sodium is a metal, chlorine is a nonmetal, and oxygen is a nonmetal. And so the electronegativity differences. Oxygen and sodium have very different electronegativities, 2.6 different, which is the ionic bond that is happening to make this an ionic compound. Oxygen and chlorine are a lot more similar, 0.5. So this is my ionic compound model. So pretty much over here we've got oxygen, who has 6 valence electrons, and it wants 2 more so that it can get all 8 on its outer shell. And so here's chlorine too, who just needs 1 more. So they're gonna bond, but that still means it needs 1 more pair. Oxygen needs 1 more pair to fulfill the octet rule. And so here's sodium over here, and sodium, it just has that 1 valence electron, but it's gonna be hard to just get a bunch of electrons. So instead, what it's gonna want to do is give the one it has away. So it's gonna give that away to oxygen, and then oxygen will have full. And then over here, that red one is supposed to represent the electron that oxygen got from sodium. And so they have the little symbols in the corner to show that oxygen gained 1, and then sodium gave away an electron. And then this little line between oxygen and chlorine is supposed to represent the pair those two now share, which is why they don't have all 4 pairs on there. So what are 2 important things about this compound? Bleach is used as a disinfectant to kill bacteria and mold. And bleach releases chlorine gas, which can be harmful to human health. And so my covalent compound is cocaine. It's got the chemical formula of C17H21N04. So carbon is a nonmetal, hydrogen, nonmetal, nitrogen, also a nonmetal, and then oxygen is a nonmetal. And so the difference in electronegativities, here they are. They all don't have much difference. So this thing on the side here isn't really that accurate. I kind of it kind of got a bit messy because there's just like so many of them over some of these circles, and like I don't know, I just, so that isn't complete, but that took too long. Hopefully it'll make sense when I explaining the actual structure here. Basically, all the hydrogens are just like attached to the carbons, because that's a lot easier than having a bunch of like, because the hydrogens can only bond to like one thing because they only have one electron. So instead of just having like a bunch of extra H's out there, we're putting them together. And tell if an atom is fully has the full 8, if it has four lines connecting to it, if it's got if it's, you know, got the pairs on the outside here, like you can see with the oxygens, and in the case of the carbons, they'll have like they'll have hydrogens to take place of the other bonds they need. So this is my 3D model for cocaine. So this is the little section that I decided to use for my Vesper model. As you can see from this image on the bottom, they are all kind of lifted up, but there's no precedent for all the balls are slightly lifted up on the Vesper geometry. In this specific set, that carbon in the middle is double bonded to one of these other carbons, so I just represented that. What are 2 important things about this compound, about cocaine? Cocaine is a highly addictive stimulant. It can be used as a prescription drug for anesthesia during certain surgeries, but it is most commonly found used illegally for enjoyment. Cocaine comes from coca leaves grown in Colombia, Peru, and Bolivia. And that's it for today's video, guys. Make sure to like, subscribe, and hit that bell